Hello, class. So today we'll be talking about the introduction to the area of major and minor segments. We'll be talking about how to calculate and solve questions when you are given segments. So as we get deeper into the topic, I believe you are going to get a lot from it. Thank you very much. Let's move over to our learning objectives. Okay, so we are now in our learning objectives for this topic, and by the end of this lesson, you will be able to understand, identify, and calculate the areas of major and the minor segments in a circle. Now, one of the major objectives for this topic is to first understand segments. How can you know that this is a major and a minor segment in a circle? How can you be able to differentiate a major and a minor segment in a circle? And how are they formed by chords? Or what is even a chord? Now, the second objective or the second learning objective is to identify the characteristics of major and minor segments while we also calculate areas of segments using the sector and triangle formulas. So the next page is to be able to know what is the major and the minor segments. Okay, so now the first question is, what are major and minor segments? What are the major segments? What are the minor segments? And now the first thing for you to know is that when a chord divides a circle, it creates two segments. When we say a chord is a line that is drawn from one part of the circle to the other side of the circle, or is a line that is drawn from one part of the circumference to the other part of the circumference. That's a chord. And now, when this line divides a circle, it creates two different segments, except if the line is drawn through the center of the circle, then it comes to become a diameter. But now we have something known as a minor segment, which is the smaller area cut off by the chord. As you can see on the diagram, that smaller area there is the minor segment, and that's a region between the chord and the shorter arc. Now we have something known as a major segment. The major segment is the larger area cut off by the chord and is the region between the chord and the larger arc. The region between the chord and the larger arc. Now, when you bring them together, the combination of the minor segment and the major segment becomes the entire circle again. So let us now move briefly into talking about the minor segments. Okay, so the minor segments. We have talked about the diagram differentiating in between the major and the minor segment. And remember, I told you that the minor segment is the smaller portion being cut off by the chord, bringing into the major and the minor segment. So, the first thing for you to know is that the minor segment is a smaller region of a circle created when into two parts. And what are these key characteristics? The key characteristics number one is that it is bounded by the chord and the shorter arc, you see. And the second is that it always smaller than the major segment. It's always smaller. One of the major ways for you to know that this is a minor segment is that it's always smaller than the major segment, and the area is equals to the sector area minus a triangle area. And then the minor segment area is a region between the chord and the arc, and it cuts off from the circle's edge. So the number one way for you to know that this is a minor segment is that it is always smaller than the major segment. So the next page will be telling us how we can also know about the major segments. So now this is a major segment. How can you know that this is a major segment? The major segment is a larger region of a circle created when a chord divides the circle into two parts. you can see that a major segment is different from the minor segment. Why is it different? Because it's the larger region of the circle. And the major points to consider on the major segment is that it contains the larger arc. It's always bigger than half the circle's area. It's the same chord creates both the major and the minor segment. It's the same chord that creates both the major and the minor segment. And the major segment area is the circle area minus the minor segment area. So these are the major things to consider when we talk about the major segment. So now let's dive deeper into calculation. Okay, so we are on calculating the segment area. There's some steps you need to look for in calculating for segment area. So to find this area of a segment, we need to understand the major components that are needed or the parameters that we make use of in calculating for the segment area. The first is the radius. The radius, as it is the distance from the center to the circle's edge, or is the distance or a line drawn from the center of the circle to any part of the circumference is known as a radius. Number two key component is the chord. A chord is a line drawn from one part of the circle to the other part. That's the chord. The third is the central angle. That's the angle formed at the center by the two radii. The angle formed is known as the central angle, and you will always be given a central angle when you are calculating the area of a segment. So the key formula here is that the area of a segment is the sector area minus the triangle area minus the triangle area. So you have to first calculate the area of a sector, and then you calculate the area of the triangle itself before you subtract or you find the difference between the two. That gives you the area of the segment. So we'll be explaining further using an example on the next page. So giving an example to find the area of minor segment, the question goes that if the radius is 10 centimeter and the angle is 60 degrees, we are asked to find the area of the minor segment. And how do we find it? Remember, it said before that it has to be the sector area minus the area of the triangle. So the area of the sector is theta divided by 360 times pi times r, or the angle divided by 360 times pi times the radius, multiplying the radius by itself. So that gives you 60 divided by 360 times pi times 10 times 10. And then the sector area, if done well, is going to be equals to 52.36 centimeter square. Then calculating the area of the triangle, it becomes half r square sine theta. That is half times the radius raised to power 2 times sine theta or sine of the angle. That is half times 10 raised to power 2 times sine 60. If done correctly, it's going to give you 43.30 centimeter square. And then finally, the area of the segment is 52.36 minus 43.30, which will give you 9.08 centimeter raised to power 2. So you can see that the area of the segment is the difference between the area of sector and the area of the triangle. So we move into the conclusion. So in conclusion, the major and minor segments are parts of a circle separated by a chord cutting through the circle. Remember I told you that the minor segment is a smaller region and the major segment is the larger region, being separated by a chord. That chord is a line that cuts across from one part of the circle to the other side of the circle. And we also calculated the area for the segment, which is the area of the sector minus the area of the triangle. Remember that this formula works for both segments. It's just that the bigger segment or the major segment usually have or always have a bigger angle than that of the minor segment. So we move over to our assignments. So our assignment is to find the area of a segment given a circle with radius 14 centimeter and a length of chord of 30 centimeter. We're asked to find the area of the minor segment using the formula that has been given. And then number two is to identify and label the major and minor segments in the circle diagram provided. And number three is to show your workings and explain each step of your calculation. It's very simple. Just use the formula and the steps that I use, and you will get your answer. So we have come to the end of the topic area of minor and major segments, and I just want to thank you for your attention, and I hope you enjoyed learning about the major and minor segments. So you are encouraged to ask your questions where necessary. Do have a wonderful time ahead. Thank you.